So welcome back, guys. So today's LeetCode daily challenge is 1335th question. That is, it is a hard level question. It is a minimum difficulty of a job schedule. So it is given that if we want to schedule a list of jobs in D days, jobs are dependent. That is, to work on the ith job, we have to finish all the jobs J, where 0 is less than equal to J is less than I. We have to finish at least one task every day. The difficulty of a job schedule is the sum of difficulties on each day of D days. The difficulty of a day is the maximum difficulty of a job done and on that day. So, if we are given an integer array job difficulty or a vector and an integer d, the difficulty of the ith job is job difficulty of I, the job difficulty of I. Okay, so we have to return the minimum difficulty of a job schedule. If we cannot find a schedule for the jobs, we return -1. Okay, so let's see the first example. Like here, job difficulty is 655 654 321. On the first day, we can finish the first five jobs from here to here. As D is given 2, so we have to do all those tasks in 2 days. Okay, on the first day, we can finish five jobs, and as the total difficulty, and the total difficulty is 6, because 6 is the maximum in the first day here. Okay, so in the second day, we can finish the last job, the last one left. So this is the minimum that we can get. Okay, we divided this vector into two parts, such as 654 321, and the max is here is 6, and and 1. So the max here in the day 2 is 1 only. So the sum is 7. So let's see the solution. Okay, here, like, day 4, days given is 4, but the job difficulty, in the job difficulty, uh, the tasks are 9, 9 and 9. So we get a -1, because if we fill if we finish a job per day, we will still have a free day and we cannot find a schedule for a given job. And like here, at the D is 3 and we have a 1 1 and 1, so we can schedule one job per day. Okay, so let's see what the solution says. As the statement states, if there are more than jobs, that is n is less than d, then it is impossible to do at least one job each day, and per the problem description, we should return -1. Okay, so then we have I as index of the first job that will be done on the current day, and day denotes, indicates the day it currently is. Okay, so DP of I day, what it will say, returns the minimum difficulty of a job schedule which starts on the ith job, uh, day comma day. Okay, so we've declared the DP here, and we have set our job difficulty as n-1. So then, what we do is, the base case is that if day double equals to d, then we return the maximum job difficulty, job of I, and that's the end of the array. Okay, so the problem says that we need to do at least one job per day. Okay, so the problem states that we at least need to do one job per day. This means we must leave the at least d day jobs, so that all the future days have at least one job that can be scheduled on that day. If n is the total number of jobs, that means from any given state, we are allowed to do the jobs from index I up to, but including that index. Okay, the difficulty of a given day is the most difficult job that we did that day. We can use that variable hardest to keep, here we have used a variable hardest to keep a track of the difficulty of that day. Okay, if we choose to do jobs up to a jth job where I is less than equal to j less than n minus d minus j, then that means on the next day we start with the j plus 1th job. Therefore our difficulty is hardest on this. Okay, so here we return dp01 because since we start on the first day with no jobs done yet. Okay, that's it, I guess. This is the solution. Let's submit it. I've already submitted once. Okay, I think it's good to go. Thank you.